As you prepare for your study of Algebra 2, you want to make sure that you review compound inequalities. So sometimes we have a statement, a math statement, where we have an amount that has two stipulations to it. So it can be like less than some amount and greater than the other. So this is called a compound inequality. You'll recognize compound inequalities because they'll have two inequality signs. This type of inequalities that we're going to talk about in this first screen, these are called and inequalities. That means that once we get down to solve the inequality, we'll see that the two criteria can happen at the same time. So we have -5 is less than some amount plus 1, which is less than 4. So if you look at my steps, you want to read the inequality from the variable in the middle. If there's any solving to do, so any math that's happening to the variable, we need to undo that on all sides at once and then reverse the inequality sign. So the first thing we're going to do is subtract the 1 from x, and we're going to subtract it from the right side and the left side. So we get -6 is less than x, which is less than 3. So now let's read this from the middle. So some amount x is less than 3, but greater than -6. So you ask yourself, can that happen at the same time? Yes, we can have amounts that are less than 3 and greater than -6. So this is why it's an and inequality, because it can satisfy both of those criteria at once. When we graph it, we're going to do an even scale, and we're going to put points at 3 and -6. It cannot be equal to those quantities, so we put open circles, and then we're going to shade everything that's in between. So let's look at the next one. The first thing we need to do in the middle is we need to add those x's together. So 1 plus 4 is 5x. Now we need to divide by 5. And we do that on all sides. So we get -4/5 is less than or equal to some quantity which is less than 0. So read it from the variable. X is less than 0 and greater than or equal to -4/5. Yes, those two criteria can exist at the same time. So this is an and inequality. So I'm going to put a closed circle at -4/5 because it can be equal to, but an open one at 0. So again, these are and inequalities because both criteria can happen at the same time. And look at the graphs. See how the shading is in between our two endpoints. We can also have what's called an or compound inequality. And you'll know it's an or inequality because it'll be written like you see below. And then when you solve it, if there's any solving to do, you'll see that those two criteria cannot exist at the same time. So the first thing we'll do is we'll add 1 to the inequality on the left and then add 2. So we get x is less than -4 or x is greater than 2. And if you think about that, that's true. That can only be one or the other. Those two criteria cannot exist at the same time. When we graph, we put an even scale and we graph both -4 and 2, open circles because they cannot be equal to. And then I show everything that's less than -4. So I'm going to shade to the left on my number line. Those are values that are getting smaller. And then I'm shading to the right of +2. All right, so the next one, we're going to add 4 to the inequality on the left and subtract 2, the inequality on the right. So we get x is less than or equal to -2 or x is greater than 3. And or makes sense because those two criteria cannot exist at the same time. We're going to graph them on the same number line, but we're going to show that the shading goes in just diverse directions. So again, this is what we call a compound or inequality. It's a compound inequality because you see 2, and these are or inequalities because you see the word or, but also logically those two criteria cannot exist at once. Look at the graphs. You will also see when an or inequality is graphed that the shading will go off in diverse directions. All right, that is a quick review of compound inequalities and or inequalities.